So here's part 2, video 5, still at the intermediate level, maybe getting a little bit tricky, so be patient and just follow the argument and then you can start coding this yourself. I want to create a function called calculate distance based on the 2 points, right? I'm not concerned in this chunk of code how it's going to do it. So imagine that calculate distance was a small business department I wanted to create. And that small business department just needs these 2 points and it will give me back the distance between them. So that sounds like a perfectly reasonable thing to do. In fact, this is very typical of how you use and create functions. You can simplify the code that you're writing by creating functions which do a lot of this detailed work, but they're out of sight. So let's create calculate distance. So you notice it's red because it's going to say unresolved reference. Let me run it just to show you the error. If I run it, click, click, it's got an error here. It says there's a name error. Calculate distance is not defined, i.e. there's nothing. What does it stand for? Where's the function it's referring to? Okay, so let's create it. Scroll back up to functions and create def. And it's called, not multiply, I don't know where that came from. We're going to call it calculate distance. And we are going to do it with point 1 and point 2. Now, a question you might feel you're asking is, what's the difference? Why am I calling these point 1 and point 2? And down here, I'm passing it P1 and P2. Why don't I call this P1 and P2? It's because this is really, really quite crucial when you understand how functions work. When I create a function, I need it to be like a little component that I can use anywhere. Not just for this example where I've got P1, P2. I might have a completely different situation. P1 and P2 are being passed to this function from here, but in another environment, it may be S1, S2, K1, K2. It could be all kinds of different possible things depending on the environment in which I'm using it. What I have to avoid doing is thinking about the environment and making my function like a black box. I've got to think about what my function is going to do entirely hidden from who is using it. Right? I'm trying to define a black box function. By thinking of it as a black box, you don't concentrate on the environment of the use, because it may be a web page, it may be all kinds of work, maybe a whole range of different things. So you try to make the code here as clear as possible in its own terms. If I'm calculating the distance, it makes sense to use the words point 1 and point 2. Now, here's an interesting thing. In my calculate distance, what I can do is for each of the points, I can grab the relative x and be done with this get x and get y. Look at this, I can go y1, and so from my point 1, I can say to it, give me your x and your y. What's clever, oops, I did that wrong. What's clever about this coding is that because I put these values in this bracket here, they're available to me here. Now, let's continue on with this. So I've got point 1, point 2. For the first point, I've got its x value, y value. For the second point, let's do x2, same thing. Let's copy and paste, let's save ourselves a bit of coding. Right. So this is, what we want to do is keep the main program out of sight. So I'm just going to scroll that off screen. Imagine this is a different environment, right? We're building a component here, x2, y2. The target environment it's being used in is not the priority here. It's to make this function, this business department, to use that analogy, as independent and as close to the outside world as possible. If you think of a function as a black box, the advantage of thinking of it like that is that it will stop you making elementary errors. Okay, so now I've got x1, y2, x2. So why don't I then define the distance x dx as the difference between these two values. Do the same thing with y, the difference between the two y values. Now, if you see what I'm doing, I'm breaking down Pythagoras' theorem into small steps, because it's this is the horizontal of a right angle triangle. Think of it like that. And this is the vertical. It's this I'm going to square, add it to this squared, and take the square root of it all in order to find the result. So let's make our next step. Should hopefully be a lot simpler and easier to understand. Now we can do something very clever. We can take dx and we can pass it the square of dx. Now this is let's do it like that, shall we? Or should we just use the function? Let's use the function math.power. I need to import the math library. Notice so I'll go from math, import everything. Okay, now if I type math and hit dot, there we go. There's a whole bunch of fantastic mathematics functions. There's one called power, which will take the first number and raise it to the second. Right, so the first number is dx, and I'm going to raise it to 2. I'm going to square it. So do the same thing with the y value. Power. Now here we are entering what you might call intermediate and quite sophisticated concept of programming. And this makes us have to temporarily pause and just ask, dx is a value which is holding the difference on this line here. When you get down to this line, we start with the right hand side, it's going to take dx, whatever that distance was, it's going to put it into this function which is going to square it. Once it's squared, it's going to pass it back to dx. Now you might say, hang on a second, that's a bit confusing. Why would you do that? You would do that because you don't need to create more variables. You can use the same variables if they're logically connected to make your code look simpler. Now those two lines now have effectively squared the x value, put the difference, and squared the y value. Go down here, and then what we need to do is set a value. Let's call it r. And it's going to be the square root, sqrt, there it is, of dx plus dy. Now that is a lot simpler to read than that really complicated version of code we had when we tried to squeeze it all into one line. I've spread it out really carefully, which is one privilege of creating a function. You can really break it down into simple, clear steps, because all of this stuff will be hidden from you. Once you write it once, you don't need to go back to it. You don't need to see it again. It's broken the steps down. So it's got dx, it then squares dx and holds it back in dx. Does the same thing with dy. Now, if you find this concept a bit tricky to understand, let's call this dx2 and dy2, so you can separate it, and that's dx2 and dy2, which are the shortcut names I'm going to give for the squared of that length and the squared of that, and that is Pythagoras' theorem complete. The very final step is I want to give that back, so I return it, and that is there's a y2 here, is that okay? It's highlighting it, no, it's fine. That is a very simple function, right, which calculates the distance between those 2 points, breaks it down into really simple steps, gets each of the values, the separation, then the square of each of those values, then puts them in a square root function and returns. Now this is why this is intermediate. It's intermediate because there's some maths in here. But if you are just coming to this for the first time, what you have to understand is I've taken how to calculate the distance and broken it into logical steps to get my result. Then look what I do. Now I've got it and I'm confident, but am I confident it works? We need to test it. We come back down to where my main code is. So there I was in my main code. I had 2 points. I wanted to get use a calculate distance between these 2 points to give me the distance. This is me using the function. And look how simple that looks. So think of it again like a business department. I ask the business department to calculate the difference. I give them the 2 points. I don't really care in this part how they do it. They just give me the result and I take the value. Right? Very, very good analogy for understanding code. Let's stop here because we're running out of time and continue in one more video.